Let us have a look at another problem where you're trying to find uh, the real root of the equation, okay, um, by Regula-Falsi method. Okay, so let us start solving this. So this is the equation where you go to find the real root up to three decimal places. Okay, so as here it is given that the root lies between there is a 2 and 2.5. Okay, so as the first process, your function which is f of x, the equation which is a f of x, which is x cube minus 2x minus 5, right? So to find that, uh, first we have to find the by substituting. Uh, let us keep this as the first root, which is a, and this is the second root, which is b. So f of a, okay, which is f of 2, okay. So as we find this 2 cube minus 2 into 2 minus 5, which gives us minus 1 less than 0. So as you see, this is negative sign, okay, and 5.25, let us say that, okay. So that is 2.5 whole cube minus 2 into 2.5 minus 5, so which is 5.625, so which is greater than 0. This is positive. So since f of a and f of b, okay, um, are of the opposite sign, the given equation f of x is equal to 0 does have the root which is m, suppose, okay, between a and b, okay. So the formula for the first order approximation of the root, which is x1, is a minus of b minus a divided by f of b minus f of a, and this is multiplied into f of a. Okay, so let us substitute this. See this, the first approximation here quickly. So let us substitute it. So here the first approximation x1, a which is 2 minus b minus a which is 2.5 minus 2 divided by f of b minus f of a, which is uh, 5.625 plus 1, okay, multiplied into minus 1. So which would results to 2.07547. Now what you got this, let us check the sign of this by substituting here in the given equation. F of x is x cube minus 2x minus 5, that is f of x1, or f of 2.07547. Okay, so please calculate this and tell me the sign of this. Okay, so while solving this, so we get this as negative of 0.21065, so which is less than 0. So uh, now as you see, it is getting closer and closer. Uh, this is 2.47 and this is 2.5. This is A and this is B now. Okay, negative and this is positive. Fine. So these are the new roots here. So we get the second approximation, keeping this as A and this as B. So as you can see here, B is constant over here. Okay, so the next approximation is this. So 2.075, which is A, minus 2.5 minus 2.07547, right, divided by 5.625 plus 0.210696, right, multiplied into minus 0, we got this result, uh, 0.0695, right? So calculate this. Yeah, we get the second approximation here. We're getting the roots closer and closer. Okay, so um, we got that as plus 0.2.0908. So uh, this is your x2. What you're supposed to do, you got to substitute in this here and get f of 2.0908. Please calculate this quickly. Yeah. So this big is minus 0.404178. Now this is less than 0, right? So as you can see, this is negative. And this is again 2.5, which is constant. So 2.5, which is positive. So this is your new A and this is B. So let us get x3 here. Please notice the values which you're getting here. I mean, this is 75, 2.075. This is 0.90. Let us see what you get. So as we got this as negative, right? So we get x3. So let us x3. We got that new root as 2.0908 minus this is 2.5 minus 2.0908 divided by 5.625 plus 0.04 178, okay, multiplied into uh, minus 0.04178, okay, so which is equal to 2.0938. Okay, so as you can see uh, here, the previous was this. Okay, now the new root which you got this, right? So as you can see here, we are trying to get closer and closer, right? So let us see whether when I substitute this root 2.0938, will it be negative, right? So for the function which is this, okay, for the function which is this, okay. So let us substitute it. Yeah. So this will be 0.838 less than 0. So as you can see here, again this is negative for 2.0938, and so this is negative, this is positive. So let us find x4. Okay, so this is 2.0938 minus 2.5 minus 2.0938 divided by 5.625 plus 0.00838. Okay, and this multiplied into this value. This is negative of 0.00838. Okay, so which results to 2.0944. So as you can see here, and this, okay, so we are getting 2.0944. So ultimately, up to 3 decimal places is required, which is m is the root, which lies between uh, these, so which is 2.094. So this is your root up to 3 decimal places. You can stop the iteration here. Now we'll do the same problem, but now I'll be using another method, which is Newton-Raphson's method. Okay, and our Newton-Raphson's method to find the approximate root here for the function which is f of x as x cubed minus 3x minus 5. And here, which is nearing to the root is given, which is x is equal to. So here your x naught which is given, or the first root which is given to you. Okay, so keeping this in mind, okay, so first thing, this is f of x is equal to x cubed minus 3x minus 5. So here you got to differentiate this, find the f dash of x, which is 3 uh, x square minus 3, or we can write this 3 multiplied x square minus 1. Okay, so the first, the general form to find the uh, roots, okay, so xk plus 1, or the order which you are going to find, xk minus f of xk divided by f dash xk. Okay, so we can write this in general form as xk minus x cube k minus 3 xk minus 5 divided by um, 3 times of xk square minus 1, or we can simplify this as 2x cube k minus plus 5 divided by um, 3 times xk square minus 1. Okay, this is for a k 0, 1, 2, 3, and so on. Okay, let us do some approximation. Um, okay, and stop the approximation where we get in the previous problem which we have seen how the decimals get nearer and nearer, so we can stop the iteration. So for k is equal to 0, so your x1 will be 2x cube x naught plus 5 divided by 3 into x naught square minus 1. So what is your x naught? X naught here is 2. So substitute it. So I'll substitute it quickly. This is 3 minus 1. So this is 21 by 9, which is 2.333 and so on. Okay, we'll do the next approximation. Okay, this is what is approximation. Okay, approximate. Good. So please calculate this quickly. On the numerator, you get 30.406318. Okay, and on the denominator, you get 13.332866. Okay, so this is 2.28055 x cube. As you can see here, there is a lot of variation with this. Here corresponding to 0.28.055, right? So this would be 2.27092. Okay, so you can see there is a zero point 0.1 decimal change here. Let us move on further. I'm substituting and getting all the values. You can cross check it. 2.2709. Oh, sorry, 90. Sorry, this is 902. Okay, 902. So as you can see here, almost the same. So you can stop this iteration. So the root will be m, which is 2.27902. This is the root. Okay, approximate root for the equation x cube minus 3x minus 5. Let's solve this problem. Okay, so as you can see here, this is a Python code for the given problem. Here's the problem. Here uh, you have the Python code here. Okay, the problem which we have done earlier, right? Fine. Now let us look into numerical integration. Okay, so we'll be trying to solve Simpson's 1/3 rule, 3/8 rule, and the Weddle. Okay, let us have a look at some of the problems here. I'll be relating to each of the problem uh, corresponding to it. So here for the Simpson's third rule, okay, 1/3 rule, okay. So let us evaluate integral 0 to 6, okay. So the function f of x or y dx, y of x dx, okay, which is 1 plus x square 1 divided by 1 plus x square dx, right? So this is your function. Okay, this whole thing is your function. Okay, and we are dividing this into equal intervals, 0 to 6, right? Into 6 equal parts. Please understand this. Into 6 equal parts, right? So the formula for this, the general formula which we write as, if it is x naught xn, this is f of x dx is equal to 1 by 3 1/3 of h interval uh, y0 plus yn nth term plus 4 times that of y1 y3, okay, all the yn minus 1 terms, okay, plus 2 times y2 y4 and all the terms of yn minus 2. So this is formula, general formula. So I need, here is 6 equal parts. So according to this, x naught is 0 and xn is 6. So your h is xn minus x naught by n, which is equal to 6 by 6, which is 1. So here the interval is 1. So we'll write the following table corresponding to x. You get y, which is the function of x, which is 1 by 1 plus x square. We'll substitute it. So for x naught as 0, you substitute it here. So 1 by 1 plus 0, which is 1. Okay. So please complete it quickly. For 1, 0.5, 2, it is 0.2, 3, 0.1, 4, 0.0588, and for 5, it is 0.0385, and for 6, it is 0.027. Okay, so the corresponding x naught, x1, okay, so we got xn, which is x6, corresponding to this y naught, y1, we got y6. So a formula comparing with this, so which is integral 0 to 6, 1 by 1 plus x square dx, which is equal to 1/3 of 1 multiplied 1, which is the same 1/3. So this is y naught, y0, y6 plus 4 times n minus 1. So you get all the odd terms, y3 and y5. Okay. And 2 times y2, y4. So we have covered y0, y1, y2, y3, y4, y5, y6. Okay, let us substitute this. So when you substitute all those values which is present here, okay, so we get as 1.3662. Okay, so this is the, so let us have a look at one more problem. Okay, okay. To evaluate integral 0 to 1, right? X divided by 1 plus x square dx. So this is your function which is f of x or y, okay, when we relate to the formula. So again, I'm using 1/3 rule here, Simpson's 1/3 rule, into 6 equal parts. Okay, 6 equal parts. Okay, fine. So your when you compare this, this is x naught as 0, xn as 1. So h is x naught, that is xn minus x naught, which is 1/6. H is 1/6. This. So x and y. So your y will be 1 plus 1 x square, right? X by. Right? So for x is equal to 0, y will be 0. X is equal to 1/6. This is 0.16 Please write down. So here are the all values. Okay. So we got this. So as you know, in the previous problem, these are your x naughts, x1 to xn, which is x6, because 6 equal parts. This is corresponding to x naught. This is y naught, y1, and this is y6. Okay. So yeah. So further, yeah, let us integrate this. X by 1 plus x square dx, which is h, which is 1/6. So 1/3 of 1/6. Why not using same thing? Okay. Why not plus y6? Okay. So this everything. So when you calculate this, get 0.3466. This is your solution. Now let us take the same problem and do it with the Simpson's 3/8 rule. So let us have a look at the general formula here. So please note down the Simpson's 3/8 rule here. So I'll be taking the same problem here. That is, let us evaluate 0 to integrate 0 to 6, 1 by 1 plus x square dx. Okay. So this is the problem. Okay, into 6 equal parts. So here, as we have seen, h will be 1. Okay, let us substitute it. We get the here corresponding to x naught, y naught. Okay, so this is the same thing which we get 1, 0.5, 0.2, and so on, right? So let us write down the formula. Dh by 8, y naught, y6 plus 3 times y1, y2, y4, y5 plus 2 times y3. So when you substitute all these values, so you get 1.3571. So you have noticed this, right? Please notice this. This is 1.3662. Here it is 1.3571. Okay. Now, using Simpson's 3/8 rule, let us solve uh, by taking for, that is, integral 0 to 1 dx by 1 plus x square. So let us do that. We'll try to solve this problem. Again, we'll take into 6 equal parts. Okay, 6 equal parts. Okay, so as you know, this x naught is 0 and xn is 1. So h will be 1/6. Yeah. So x and y, write down quickly. So you can see this by putting x values. Okay, you get y, right? So since it is 6 equal parts, okay, I'll be using the same formula here, right? So let us substitute this and find 0 to 1 dx by 1 plus x. It's x squared. Okay? So which will be 0.6932. Okay. Now, so uh, so let us look the same thing, and that is integral 0 to 1 x by 1 plus x square by using Simpson. So we will see whether we get this result. Okay, so let us see that. 1 plus x squared dx. Okay. So here again 0 to 1, and we'll find 3 equal parts. So your h will be 1 by third. Okay. So write down the table corresponding to this. So this will be 0, this will be 3/10, this will be 6, 13, 6 by 13, and this is 1/2. So you got y0, y1, y2, y3. So the corresponding formula, since we have got 3 equal parts, so it is 3h by 8, y0, y3 plus 3 times y1, y2. Okay, so when we compute this, get this. So have you notice that this is 0.34807. Okay, and the one which we got this earlier, 0.34661. Okay, let us move on to the next and the last rule, which is Weddell's rule. Okay, we'll, we'll write down. Now, this is the formula for Weddell's rule, right? We'll be using it. Now, again, I'll be taking the same function and we'll integrate it. So, let us evaluate. That is x by 1 plus x square dx, right? 0 to 1. Now, this is again 6 equal parts. Okay. So, here again, x naught is 0, xn is 1, and h is b minus a divided by, that is x. This will be 1/6. Okay, because 6 equal parts. So this is 0 to 1. This is f of x dx. Okay, so which is 3h by 10, right? y0, y6 plus y times y1, y5 plus y2, y4. Okay, and 6 times y3. Okay, so we have covered everything. First, the last, okay, 5 times yn minus 1 term and n minus 1 and n minus 5, n minus 2, n minus 4, n minus 6, okay, so n minus 2. So let us substitute it. So we got this as 0.346567. So this is your final answer. So have you noticed that? So this was the previous one. Okay, we are getting the approximation. Right? Okay, yeah.